Hi, all. Good morning. Can you please confirm my voice is audible or not?
Yes, sir, audible.
And hope you are able to see my screen also.
Yes, sir.
Thank you. Hello. So actually, as part of our previous session, so we discussed about our compute engine, and we discussed about how to create virtual machines. You can call it as instances also. And we discussed about how to do this activity from console and also from Cloud SDK. And after that, we discussed about how to connect to compute engine through partition. Because in real time, we will connect in this way only. So if you are going to work on the real-time projects, we are going to connect to compute engine by using the partition. So that's the reason we discussed about how to install the partition and how to use the partition and how to create the keys, how to assign the keys, and all these topics we covered as part of our previous session. At the same time, we discussed about by using partition, how to run Unix commands, and we discussed about by using compute engine, how we can host a basic web application. So these are all the topics we covered as part of our previous sessions. In the last 3-4 sessions, we discussed about the compute engine. Within the compute engine, we discussed about all these topics on it. Now, as part of today's session, we are going to start discussing about one important topic or a new topic called as a BigQuery. So indirectly, I can able to say this is the one of the important topic as part of our cloud data engineering course. The very important topic as part of our cloud data engineering course. And I can able to say in real time, most of the time, you will work on BigQuery as a cloud data engineer. So if you are going to work in the real-time projects as a cloud data engineer, after completion of the course, you need to attend the jobs. And after getting the jobs, what you are going to perform in the real-time projects, most of the times you are going to work on the BigQuery. And as part of interviews also, you will face questions on BigQuery. So why I'm telling all these 3 points here is you need to understand what is the importance of the BigQuery here. So from the course perspective, this is the one of the important topic. And if you're going to work as a cloud data engineer in the real-time projects, then also this is one of the important one. At the same time, if you're going to face the interviews as a cloud data engineer in that at that point of time also, you will get the multiple questions on the BigQuery. That's the reason. So I can able to say BigQuery is the one of the very, very important concepts. Mostly next 5 days or 7 days, completely we are going to focus on the BigQuery. So please don't miss the classes when we are discussing about the BigQuery. Not only BigQuery, and if you are discussing any topics, don't miss the classes. If you are going to miss one class, you won't able to understand from the next class what we are discussing and what we discussed in the previous classes. That's the reason don't miss the classes and try to focus very properly on the BigQuery, because this is the one of the very important concept from the cloud data engineering perspective. Okay. Now we'll try to understand what is BigQuery. So we'll try to understand what is the BigQuery. In the simple words, we can able to say Google BigQuery is a cloud data warehouse. So in the simple words, we can able to say Google BigQuery is a kind of a cloud data warehouse, and this is GCP fully managed service. So in the simple words, if you want to understand, we can able to say Google BigQuery is a kind of a cloud data warehouse, and this is GCP fully managed service only. So earlier we discussed about the Google Cloud Storage and we discussed about the Google Compute Engine. Those are also comes under the GCP managed services only. And in the same way, BigQuery also will comes under GCP fully managed service. But here main thing we need to understand what is the purpose of the BigQuery. So what I'm telling here we are calling it as a Google BigQuery is nothing but it is a cloud data warehouse. And if you remember, in the one of the class we discussed about what is data warehouse. If anyone remember, please tell me the answer. What is data warehouse?
To store the unmanaged data. To store
We can able to say
collection of
data from
different sources.
Types of the sources, and we are converting that unorganized data into
Managed
organized
Organized
format. Why we are doing this activity? For the purpose of
analysis.
doing analysis to take the decisions. So this complete activity only we can able to call it as nothing but data warehouse. And in the previous classes, we discussed with one example. I given the Citibank example. With the Citibank example, we discussed about what is the data warehouse. So data warehouse is nothing but collection of data from different types of the sources, and we are converting that unorganized data into the organized format. Why we are converting unorganized data into organized format? For the purpose of doing analysis to take the decisions. Now this is the definition of the data warehouse. But if you want to build the data warehouse system, earlier on-premise, if you want to build a data warehouse system on-premise, earlier we are using Teradata or we are using Oracle. So like this, we are using some different databases for the purpose of maintaining our data warehouse systems only. What is meant by on-premise? This also we discussed in the previous classes.
It's within a local system.
Within our local system, if you are maintaining any software or if you are maintaining any kind of servers or anything, that only we can able to call it as a on-premise system. But now what we are doing, we are moving everything to the cloud only. By using the cloud, if you are going to maintain the servers or if you are going to maintain the software, such kind of systems, we can call it as a cloud systems. Earlier we discussed about what is the difference between the on-premise systems and cloud systems. As part of this topic, just I want to recall the topic. So here in the on-premise or in the earlier, what happened is on-premise by using Teradata or by using Oracle or by using the SQL server, we build data warehouse systems. And if you remember, we discussed one more topic in the previous classes, Andy. As part of data warehousing projects, we are going to perform the operations called as nothing but ETL operations. ETL is nothing but extraction, transformation, and loading operations. In the data warehousing projects, we are going to perform the ETL operations, which are nothing but E for extraction, T for transformation, and L for loading, and collection of the data. Simply what we can able to call collection of data is nothing but extraction. And after that, we are converting the data from unorganized format to organized format. That only we can able to call it as a transformation. After converting the data into organized format, we are going to perform the loading operation. So this kind of operations only we can able to call it as a ETL operations only. Generally, where we are going to perform the ETL operations, we are going to perform the ETL operations in the data warehousing projects. Now tell me, in the legacy or in the on-premise, if you want to perform the ETL operations, what are the tools we are going to use? That also we discussed in the previous classes. We are going to use ETL tools. What are the tools we are having in the market?
Informatica,
We are having
Informatica,
Informatica,
data
data stage,
stage,
Ab initio.
Ab
So like
initio.
this, we are having different ETL tools in the market. Indirectly, I'm trying to say in the legacy systems or in the on-premise systems, to build the data warehouse, we need to perform the ETL operations. As part of doing the ETL operations, we need to use the ETL tools. What are the ETL tools we are having earlier or in the legacy or in the on-premise? We are having Informatica and data stage and Ab initio. By using these ETL tools, we are going to perform the ETL operations. By performing ETL operations, what we are doing? We are building the system called as a data warehouse. Now, on-premise, if you want to build the data warehouse systems, in which database we are going to store the data? We are going to store the data either in the Teradata, or we are storing it in the Oracle, or we are going to store it in the SQL Server. But all these things are happening in the on-premise. And again, as we discussed earlier, what are the disadvantages if you are working in the on-premise?
We cannot store huge amount of data.
So one thing,
It is in terabytes or
you need to set up everything from scratch. Now, for example, you want to use the Teradata and you want to use the Informatica for the purpose of doing ETL operations, Teradata for the purpose of storing the data. Now, if you want to build the data warehouse on the on-premise system, so if you want to install the Teradata or if you want to install the Informatica, we need to spend good amount of time. At the same time, to maintain all these things, we have to maintain the servers also, Nandi, which is nothing but here I can able to say. From scratch, we need to install all the servers and we need to install all the softwares. Okay, so to perform all these kind of activities, what will happen? It will take good amount of time. So just I'm repeating the one of the topic which we discussed in the previous classes. What are the disadvantages if you are going to work on the on-premise system? So we need to set up everything from the scratch, which is nothing but you need to create the servers, you need to install the software, and you need to perform all the activities. You in the sense our admin team. So we are not going to do these activities in the on-premise also. Our admin team will perform all these activities. But even if admin team want to perform all these activities, it will take good amount of time. And this is for setup. After setup, again, what need to happen? For maintenance. Maintenance also will take good amount of time. And third one, from the cost perspective, we need to spend more money. Okay, so indirectly, and one more thing is, if you want to increase the softwares or increase the servers or decrease the servers as per requirement, it will take good amount of time. Okay, so indirectly we can able to say if you are going to work on the on-premise systems, these are all the different disadvantages we are going to face, not only for data warehouse systems only. If you are going to work for any kind of applications on the on-premise, definitely we need to perform all these kind of activities. You need to set up the servers, you need to install the softwares, and you need to perform the maintenance activities, and you need to spend good amount of money for the purpose of all this setup. At the same time, whenever you want to increase the number of servers or whenever you want to decrease the number of servers, we need to spend good amount of time. So all these are the disadvantages we are having on the on-premise systems. Okay. Now, if you want to build the data warehouse by using Teradata or by using any ETL tool on the on-premise system, all these are the disadvantages generally we will face on the on-premise system. Now, to avoid all these things only, to avoid all above disadvantages, we can build data warehouse system by using cloud. So what we are doing here, simply we are going to build the data warehouse system by using cloud. Now within the GCP here, if you want to build the data warehouse system, what is the service we are using here? We are using the one of the service called as a BigQuery only. So to avoid all the above disadvantages, simply what we are doing here, we are moving to the cloud. In the cloud, what we can do here, by depending on our requirements, we can able to build the data warehouse systems. But as part of GCP, if you want to build the data warehouse system, what is the service we are going to use? We are going to use the service called as nothing but BigQuery. If you remember earlier, we discussed about this. This we can able to call it as a data warehouse as service. So what are the different types of services we are having in the cloud? IaaS, which is nothing but infrastructure as service. SaaS, which is nothing but software as service. One more thing, PaaS, which is nothing but platform as service. So like this, we are having the mainly three different services. Other than this, we are having big data as service, storage as service, data warehouse as service, ML as service, IoT as service. So like this, we are having the different types of the services that also we covered as part of our previous sessions. And now here we are discussing about the BigQuery, and BigQuery we can able to call it as nothing but data warehouse as service. Now indirectly here what I'm telling at the beginning statement, I mentioned that BigQuery is nothing but is one of the cloud data warehouse system. But where we are having the BigQuery, we are having BigQuery in the AWS or Azure or in the GCP. We are having BigQuery in the GCP. That's the reason just we are mentioning it as this is the GCP fully managed service. But here we are trying to understand what is the data warehouse. As I told you, data warehouse is nothing but collection of data from different types of the sources and converting the data into organized format for the purpose of doing analysis to take the decisions. But on the on-premise systems, what we are doing, we are creating the data warehouse systems by using the databases called as Teradata or Oracle or SQL Server. At the same time, as part of data warehousing projects on-premise, if you want to perform the ETL operations, we are using the ETL tools like Informatica, DataStage, and Ab Initio. And whenever we are going to work on the on-premise systems, what all are the disadvantages we are having? You need to set up everything from the scratch, servers or softwares and everything. We need to set up everything from the scratch. At the same time, maintenance also will take very good amount of time as part of your on-premise systems, and cost perspective also we have to spend very good amount of money. And if you want to increase the servers or if you want to decrease the number of the servers as per the requirement, it will take very good amount of time. To avoid all these disadvantages only, what we are doing here, we are moving to the cloud for the purpose of building our data warehouse system. Now, which cloud platform we are using as part of our classes? We are using the GCP. Now, within the GCP, if you want to build the data warehouse systems, what is the service we are using here? We are using the service called as BigQuery. This is the way simply we can able to understand why we are going to use the BigQuery and what is the purpose of the BigQuery in the simple terms. Simply we can able to say BigQuery is a cloud data warehouse and this is one of the GCP fully managed service. Okay, up to here, any questions or any confusions, please ask me.
Sir, what's the link in between BigQuery, SQL, and data warehouse?
See here, actually, so here we are calling BigQuery as a service. Okay. Now tell me, for example, earlier we discussed about the cloud storage only. So what is the cloud storage? That is the service. Why we are using the cloud storage? For the purpose of storing the data, by creating the buckets, by creating the files, and by uploading the files. What we are doing, we are storing the data in your cloud storage service, right? In the same way, here what is the BigQuery? BigQuery is a service. And why we are using the BigQuery? For the purpose of building our data warehouse systems. So just so you can understand, you can compare the BigQuery and cloud storage like this only. What is the purpose of cloud storage? For the purpose of storing the data in the files format. Coming to BigQuery, what is the purpose of the BigQuery? For the purpose of building our data warehouse system, GCP given a service called as BigQuery. In the same way, in the cloud storage, what operations we have done? We created the buckets, we uploaded the files. What types of files we uploaded? We uploaded the CSV files or JSON files, whatever the kind of files you want. You can able to upload the different types of the files into your cloud storage for the purpose of storing the data. In the same way, within the BigQuery also what we are doing, we are building the data warehouse system. And where we are building the data warehouse system? In the BigQuery. Now within the BigQuery, whenever you want to build the data warehouse system, indirectly we are going to maintain the databases and we are going to maintain the tables and we are going to maintain the views. So what I'm telling here, by using the BigQuery, we are building the data warehouse system. BigQuery is one of the service we are having in the GCP. What is the purpose of the BigQuery? For the purpose of building our data warehouse system. What is the purpose of data warehouse system? To convert unorganized data into organized format and to do the analysis and to take the decisions. We are using the data warehouse system. Now within the data warehouse system, what we need to maintain? We need to maintain the databases, we need to maintain the tables, and we need to maintain the views only. Now tell me, whenever we are going to maintain all these things, databases or tables or views, what is the language we need to use as we discussed in the database concepts?
SQL.
We need to use a language called as a SQL. Okay, this is the way simply you can able to link everything only. BigQuery is a service. By using the BigQuery, we are going to build the data warehouse system. What is the meaning of building the data warehouse system? In the data warehouse system, we are going to maintain the databases, we are going to maintain the tables, and we are going to maintain the views. And if you want to maintain all these kind of things, or if you want to access all these kind of things, we are going to use a language that only we are calling it as nothing but SQL language. This is the way you can understand the link between the BigQuery and data warehouse and SQL. But up to here, I haven't discussed about anything about all these things in the BigQuery and first to try to understand what is the purpose of the BigQuery. So by end of this class, or once we are going to complete some kind of practical sessions, then you can understand what is the relationship between the BigQuery and data warehouse and database and SQL. All this kind of understanding you can able to get by end of this class, or at least by end of the tomorrow's class. Is it clear? Okay. Any other questions so far? If no questions, see here, this is for our easy understanding, because first time we are discussing about the BigQuery. Just for the easy understanding, I given the simple statement called as nothing but BigQuery is a cloud data warehouse only. But if you are going to the interview, if they're asking the question, what is the BigQuery? If I'm going to give the one word answer, it is a cloud data warehouse. Is it the correct answer? No, right? In the same way, if you want to understand in detail about the BigQuery, if I'm going to say simply it is a cloud data warehouse, then also we can able to say with that single statement, you cannot able to understand properly what is the purpose of the BigQuery. Now we'll try to understand in detail about the BigQuery only. But even if you are going to discuss about the in detail or in the simplest format, at the high level, we can able to say BigQuery is nothing but it's a kind of a cloud data warehouse. That is, we are calling it in the simplest format for understanding purpose. But if you want to give the proper definition of the BigQuery, we can able to give the statement like this. BigQuery is a cost-effective, serverless, auto-managed, multi-cloud, highly scalable, highly available, and cloud-based data warehouse. So what I'm telling here, just I'm adding the multiple words as part of defining the BigQuery here. At the beginning, I given the just a high level statement for the easy understanding. Now just I'm adding the some more words in for the discussion in detail only. So here I'm saying that BigQuery is a cost-based, cost-effective, serverless, auto-managed, multi-cloud, highly scalable, highly available, and cloud-based data warehouse. This can handle, or I can able to say, this service can handle huge amount of data within seconds. So huge amount of data is nothing but indirectly we can able to say where it is going to handle petabytes of data within seconds. Now don't get the confusion here. I will explain about all these words one by one only. But in general, if anyone is going to ask the question, what is the BigQuery? If you want to give the detailed answer, we can able to say simply BigQuery is a cost-effective, serverless, auto-managed, multi-cloud, highly scalable, and a highly available cloud-based data warehouse. Highly available cloud-based data warehouse. And with the help of this BigQuery service, what we can do here, you can able to handle very huge amount of data. What is meant by huge amount of data? You can able to see that we can call it as a gigabytes of data, or we can call it as a terabytes of data, or we can call it as a petabytes of data, or we can able to call it as a zettabytes of data only. So it can able to handle any huge amount of data within seconds, or at most we can able to say within minutes. For example, if you are going to deal with the petabytes of data, it can able to handle the query execution within the seconds. But if you are going to deal with the zettabytes of data, then what will happen? It can able to handle the query transactions, or it can able to execute the queries within the minutes. Indirectly, whatever the huge amount of data we are going to deal by using the BigQuery, you can able to process that data very fastly. Automatically, it is performing all these operations by using our GCP platform. Now we'll try to understand what is meant by cost effective. We'll go one by one. You only try to give the answer. Cloud-based systems are cost-effective, or it is going to apply the more cost compared to the on-premise?
No. Compared to the on-premise, it's low cost.
Compared to on-premise, it's a kind of a low cost. So earlier we discussed about 7 different properties of the cloud. If you remember, we discussed about high scalability, high availability, fault tolerance. So like this, we discussed about 7 different features of the cloud. All those features are going to applicable for each and every service, whatever we are going to discuss. So one of the features we discussed it as a cost effective. Now coming to BigQuery, what I'm telling, BigQuery is a cost effective, which is nothing but we need to pay very less amount of money, or we can able to say we need to pay whatever we use. So whatever we use as part of BigQuery, only for that only we have to pay the money and so no need to pay any extra amount as part of using the BigQuery. And one more thing here, what will happen is as part of using the BigQuery, they will apply the charges like this. One is for compute and second one is for storage. So what they are doing here, they are charging for two different reasons. One is for compute and one is for storage. Now compared to storage, I can able to say here, compared to storage for compute,
Less.
we need to pay more. And coming to storage, we need to pay very, very less amount. See here, actually I can able to say compute and storage for both the things we are going to say pay the very less amount of money. But here just I'm comparing the compute and storage only. So what I'm saying here, compared to storage, for compute we need to pay the more amount, which is nothing but as part of using the BigQuery, they are going to charge more money for the compute operations compared to storage. Coming to storage, they are going to charge the very less amount, and for compute also they are going to charge the less amount only. But here I'm saying that compared to storage, they are going to charge the some more amount on top of your compute. But tell me here, what is meaning of compute? Now, for example, by using the BigQuery, I am going to write the query like this. Simply select star from my table. So within the BigQuery, we can able to run the queries by depending on our requirement and so whenever we are going to run the queries, what will happen in the backend? It will perform the compute operations. It is going to fetch the data from your BigQuery storage, and from that it is going to retrieve the data. That data will be coming on top of your output. So this operation simply we can able to call it as a compute operation. Now as part of this compute operation, what is going to happen? Whatever the amount of data it is dealing, for that it will charge money. Now, for example, see here, I am given the query called as a select star from the table. I am given one more query called as, for example, select star from table. I am applying the where condition as, for example, department ID is equal to 20. Now you tell me, out of these two queries, which query will charge more money in the BigQuery?
First query, select star from table.
See, out of these two queries, and in the first query, what we are doing, we are given the select star from the table, which is nothing but what indirectly you are performing the compute operations on the complete table, or you are performing the compute operations on the only particular data. Here we are dealing with the complete table data because we are given the star from the table, which is nothing but it is going to retrieve the complete data from the table. Indirectly, you are performing the compute operation on top of the complete table. For that reason, compared to the second query, first query will charge the more money. Now coming to second query, what I'm doing, I am limiting the data. I am giving it as a select star from the table. I am applying the condition called as a where department ID is equal to 20. With that, what I'm doing here, I am limiting the data. Indirectly, I can able to say first query, for example, dealing the 1 GB data. But coming to second query, because of given the filter condition, it is dealing only 0.5 GB data. By considering that, we can able to say first query will charge more compared to the second query. Now, for example, here I'm given the one more query like this: select star from table. Just I'm giving it as a limit 1. Now you tell me, out of these three queries, which query will charge very less amount of money?
Last
One, because in the last
one.
query, what I'm doing, just I'm giving the condition as a limit 1. What is the meaning of limit 1? And it will handle only one record from the table. Now, first query, for example, dealing with the 1 GB data. Second record is dealing, for example, 0.5 GB data. But coming to third query, just we are handling the only one record, which is nothing but might be we are dealing with the 10 KB data or 20 KB data. Because of that reason, your third query will charge the very less amount of money compared to the above two queries. Indirectly, here we need to understand all the charges are happening on top of your compute operations. Whatever the queries we are going to run, based on those queries, they are going to charge the money. At the same time, in the BigQuery, other than execution of the queries, what we can do, we can able to do the storage operations also. For the purpose of storage in the data also, they are going to charge the money. For computing, they are charging, and for storage also they are charging. For both, they are going to charge the very less amount of money. But when we are comparing the compute and storage, for which they are charging more? When we are comparing the compute and storage, for which they are charging more? For the compute, they are charging more compared to the storage. Okay, all these are the things we need to understand as part of your cost effective. Okay, again I'm repeating the same statement, don't get the confusion. Only for compute and storage, they are going to charge the very less amount. But when you want to compare the compute and storage, as part of comparison, I'm saying that compute, they are going to charge more compared to the storage. But in general, if you want to say compute is a very simple operation and storage is also very simple operation from the charges perspective. That's the reason we are calling it as a BigQuery is a one of the cost-effective solution to build our data warehouse system. Okay. Now, in the same way, we need to understand the second word called as nothing but serverless. If you remember, above I told you, right, if you want to maintain the Teradata on the on-premise system, or if you want to install the, if you want to maintain the ETL tools like Informatica and Data Stage, definitely we have to maintain the servers and we need to maintain the nodes in the on-premise system. But coming to BigQuery here, no need to maintain any servers from our side. See, generally in the cloud also, whenever we are going to maintain the big data systems or whenever we are going to maintain the Hadoop systems, and we need to create the clusters. As part of creation of the clusters, we need to define how many number of nodes you want to maintain. All these kind of inputs we need to provide. Just I can able to say, when you want to create the clusters, we need to specify how many nodes you want to maintain. Whomever not talking, can you please go on mute, online people? We need to specify how many nodes you want to maintain and what is your system configuration. So these kind of details we need to provide even in the cloud also. In the cloud, we need to provide these kind of details whenever we are going to create the clusters as part of handling our big data services or as part of handling our Hadoop services. You need to create the clusters. As part of creation of the clusters, we need to specify how many nodes you want to maintain and what is your system configuration. All this information we need to provide. Okay. But whenever we are going to use the BigQuery, no need to provide any kind of inputs, and indirectly, no need to maintain any kind of servers from our side, or I can able to say, no need to define anything from our side. Okay, so from our side, we are not going to specify how many number of nodes you want to maintain or what is the configuration you need to maintain. All these kind of inputs no need to specify from our side. That's the reason only simply we can able to call it as nothing but serverless. Indirectly, earlier we discussed about, if you in the previous statement I told that it can able to handle the petabytes of data. It can able to handle petabytes of data within seconds. But how it can able to possible, any guesses? How it can able to handle petabytes of data within the seconds? Internally, it is going to perform the operation called as nothing but distribute operation. What is meant by distribute operation? This is the one more topic again we discussed in the previous classes.
It will like equally shared.
Now see, for example, you want to maintain the 10 GB data by using the single server. This is the option one. Second option, you want to maintain the 10 GB data by using the 10 different servers. Now, in which option we can able to load the data fastly, and in which option we can able to retrieve the data fastly?
Second option.
In the second option, because in the second option, how many servers we are maintaining? We are maintaining the 10 servers. When we are going to perform the 10 GB data, automatically what will happen? All this 10 GB data will distribute to all the 10 servers, which is nothing but your data will load in parallel. Because of loading the data in parallel, what will happen? You can able to load the 10 GB data within 1 minute or within 2 minutes. In the same way, as part of retrieving also, what will happen? You are having 10 GB data in the 10 servers. When we are going to retrieve the data, you are retrieving the data from the single server, or you are retrieving the data from the 10 servers in parallel. We are retrieving the data from 10 servers in parallel. For that reason, what will happen? You can able to retrieve the data also very fastly. That kind of operation only we can able to call it as a distribute operation, or we can able to call it as a parallel operation only. So whenever we are going to maintain the multiple servers, your loading activity will take less amount of time. At the same time, your retrieval activity also will take very less amount of time. Indirectly, to improve the performance, obviously we have to maintain the multiple servers, and by using the multiple servers only, you can able to load the data fastly and you can able to retrieve the data fastly. Now, what I'm telling here, by using the BigQuery, we can able to handle petabytes of data within seconds, which is nothing but BigQuery is going to provide the best performance compared to all other systems only. But how it is possible? In the backend. In the backend, what they will do? they will maintain so many number of servers in the backend, and they will take care of this distribution operation, or they only will take care of the parallel operation. But as a user or as a cloud data engineer, do we need to worry about how many servers we need to maintain in the BigQuery? Do we need to worry about how we need to perform the parallel operation? Do we need to worry about how we need to perform the distributed operation? From our side, no need to worry about all these kind of things, because we are not going to maintain any kind of servers from our side. Your GCP platform will maintain all the servers in the backend. With that, automatically you can able to get the very good performance as part of loading the data and as part of retrieving the data also. That's the reason only we are calling it as this is the serverless service. Okay, don't think that when I'm calling it as a serverless, some people are thinking that BigQuery will not use any servers internally. But tell me, is it the correct statement? When I'm calling it as a serverless, some people are thinking that BigQuery will not use any servers internally. Is it the correct statement?
No.
This is the wrong statement. And see here, without having the servers or without having the data storages, your BigQuery also cannot able to store the data, cannot able to perform the compute operations. In the BigQuery also, what need to happen in the backend? They need to maintain the servers and they need to maintain the storage areas and everything. But here, why we are calling it as a serverless? From our side, from the user side or from the cloud data engineer side, we are not defining any kind of servers. You are not maintaining any kind of servers. For that reason only, we are calling it as a serverless. And this is the one of the best feature we are having as part of the BigQuery. You can able to get the very good performance without maintaining any kind of servers from your side. That's the reason most of the companies are now migrating to the BigQuery. Okay. Any questions on this serverless statement? Please ask me here.
Sir,
Just here
I have a question.
Yes,
On
please.
not, I mean, it's not on serverless, but in the select star in the SQL query.
Yeah.
You said that select star from table limit 1. This gives the best, right?
Yes.
So here, my doubt is when we are performing select star from table, it computes the whole table, and then when displaying it limits to one record, right? So that means anyway it has to perform the complete operation, right?
No. See here, actually, what will happen here is they are going to consider how many records they are dealing finally while displaying the data. That is the one they are going to consider. So as a part of this query, what is happening? Finally, how many records they are going to display? Only one record. But commenting here, what is going to happen? There, for example, if they are having the 10 lakh records only, they need to handle the compute operation on the 10 lakh records. At the same time, as part of retrieving the data or as part of displaying the data also, they need to deal with the 10 lakh records. But commenting here, as part of displaying the data, how many records they are dealing? They are dealing with only one record. Okay, that's the reason compared to the first query, second query will charge the less amount of money. Is it clear? As part of retrieving, both the queries might be retrieving all the records, but actually here what I am doing, I am performing the limit operation. For example, same query I will do like this. I am giving it as a, for example, sum of sal. Just I am giving the sample example only. Now you tell me in the first query what is happening, or I am giving here, for example, sum of sal here also for understanding purpose. Now in the first query, what is happening? From the table, it need to fetch all the 10 lakh records. For all the 10 lakh records, it need to perform the sum operation. But coming to here, what is happening? It is fetching all the records, but we are limiting it to only one record. Now here for only one record, we are doing the summing operation, or we are doing the summing operation for all the 10 lakh records in this query. We are doing the summing operation for only one record, okay? Because we are given the limit 1, which is nothing but it is taken the only one record, or if you want, I can give the condition as like this. I am given the condition as where department ID is equal to 20. Okay. Now in the first query, what is happening? It is performing the summing operation, or it is performing the computing operation on top of your 10 lakh records only. But coming to this query, what is happening? When we are given the where department ID is equal to 20, for example, we are having the only 1000 records. Only for 1000 records, it is performing the summing operation. Indirectly summing operation, we can able to call it as a compute operation. Now you tell me, performing the compute operation on 10 lakh records is costly, or performing the compute operation on 1000 records is costly? Which is the costly one? Obviously, performing compute operation on 10 lakh records is the costly operation. That's the reason this query will take more amount of time. Sorry, this query will charge more compared to this query only, because here we are applying some kind of filter. After applying the filter, we are performing the compute operation. That's the reason in the BigQuery at any point of time, try to apply the filters if possible. I'm saying by depending on the requirement, try to apply the filters. By applying the filters, we are going to deal with the less amount of data. With that, what is going to happen? We are going to save the money as part of using our BigQuery service. Is it clear?
Yes, sir.
Okay. Any questions on the serverless? Okay, I will ask a
Sir,
question. Try to tell me. Yeah, please.
Yeah, I had a question. So if the client is single tenant client and there are actually two types of clients, like single tenant and also shared tenant clients. So in serverless, you said that there is a distribute operation, right? So is it like based upon a client, it will be like, or else is there any feature of single tenant, like if you want to opt only, if you restricted to only one single client, is it possible on cloud, sir? Or
What do you mean
else?
by tenant?
Mean like if I had like a client like Wipro, he wants only few servers that is dedicated to him, and also the services that no one, like if we can take some data, you said that it will be shared between different servers, and is it possible, sir, like only that limiting all the servers and some services to some single client? Is it possible on cloud,
See,
sir?
here if you observe, here I'm telling it as a serverless. Indirectly, as a user, you are not dealing anything with the servers. By considering the statement, you tell me the backend can be able to control the services servers here, at least in the BigQuery.
No.
No, right? So which is nothing but as part of using the BigQuery, you cannot able to perform any kind of controlling operations on top of your servers only. So by depending on the amount of data which BigQuery is dealing, it will take care of the number of servers and whether how many servers they need to maintain, what is the configuration they need to maintain. Everything your BigQuery only will take care. We cannot able to control the servers as part of using our BigQuery service. Now, for example, today I'm dealing with the 10 GB data. In the backend, what BigQuery will do, it will create the, for example, 5-node cluster. Now, for example, if you are going to maintain the tomorrow 1 terabyte of data, then what will happen in the backend might be to create the 10-node cluster. Like that, BigQuery will take care of all these operations. You cannot able to have any kind of control as part of handling the clusters or servers as part of using the BigQuery. Simple answer for your question. You cannot able to control the server operations, or you cannot able to control the clustering operations as part of using our BigQuery service. Is it clear?
Okay, sir. Like on-premise, like we have actually some single tenant client. So we are only some dedicated services, and also servers will be dedicated to that client only.
Okay.
There are also some multi-tenant clients there where all the servers are shared within them. So it is one of the backdrop for in the cloud, sir. Is it? So
It's
because
not
it
like,
is
no, see, actually, if you want to maintain that, what we can do here as part of creation of the database in the BigQuery also, we are going to specify the locations, and by using the locations, we can able to differentiate the server locations if you want.
okay.
Okay. So if you remember, as part of creation of the cloud storage buckets, also we given the locations, right? Like EU, US, like that, we given the different locations, right? In the same way, if you want to differentiate your tenants only, so in the situation, what we can do here, by given the different types of the locations, we can able to differentiate the servers. That we cannot able to say it as a disadvantage because of using the cloud. Okay, you can able to handle that, but here what I'm telling is, so as part of using the BigQuery, we cannot able to control that operation, but as part of creation of the databases, there we need to specify one input parameter called as a location. So there we can able to specify all these kind of details where you want to create the BigQuery service or where you want to create the database by depending on the requirement. So with that, we can able to handle all these kind of things. Okay. Okay, just we'll move on. So here we discuss about the cost effective, then we discuss about the serverless. Now you try to give the answer. Indirectly, we discussed about this already. What is meant by auto managed? As I told you, as part of this topic, are we maintaining any servers? No. Are we stopping any servers? No. Are we decreasing any number of servers here? No. Are we increasing any number of servers here? No. Which is nothing but whatever the amount of data we are dealing here, we are not performing any kind of operations in the backend side only. Your BigQuery itself is managing everything. If you are dealing with the 1 terabyte of data, it will handle the servers differently. If you are going to deal with the 10 terabytes of data, it will handle the servers differently. If you are going to deal the petabytes of data, also what will happen? Your BigQuery itself manage everything automatically. That's the reason here we can able to say BigQuery is kind of a auto managed service. By depending on the amount of data in the backend, it will manage everything. So for that reason, simply we can able to call BigQuery is nothing but it's a kind of a auto managed service. Okay. In the same way, here we are using the one more word called as nothing but BigQuery is a multi-cloud service. What it means in any cases?
Yes, sir.
BigQuery is a
Like
multi-cloud service, which is nothing but. Now tell me here first. BigQuery is provided by which platform?
GCP.
GCP, right? Now, by using BigQuery, if you want, we can read data from AWS or Azure by depending on the requirement. And in some projects, what will happen is they are going to maintain the multiple cloud platforms. So in the same project, we can able to see the AWS and GCP. In the GCP, for example, you are maintaining the BigQuery. For example, see here. In the GCP, if you want to store the data, what is the service we are using for storage? As per our previous
GCS.
classes, we are using the cloud storage service, which is nothing but GCS. Okay. Now, in the same way, in the AWS, if you want to maintain the data, or if you want to store the files and read, there we are using the service
S3.
called as nothing but S3. Okay. Now, by using BigQuery, what we can do here, you can able to connect to GCS service. But tell me where we are having the BigQuery. BigQuery is present in the GCP Google Cloud Platform, and where we are having the GCS also present in the same GCP platform, which is nothing but within the GCP or within the cloud, you can able to connect to multiple services in the very easy way. Andy. But here, what is the one more feature they are providing here? By using the BigQuery, if you want, as per your requirement, by using BigQuery, you can connect to S3 buckets also. So where we are having the S3 buckets, the S3 bucket we are having in the AWS, which is nothing but, so by using the BigQuery, you can able to connect to the GCP directly. By using the BigQuery at the same time, what we can do by depending on our requirement, if you want, we can connect to the AWS, and from the AWS, we can able to read the data from the S3 buckets. Okay. Now in the same way, by using BigQuery, if you want, we can connect to ADLS, which is nothing but Azure Data Lake Storage. Actually, this is the one of the storage service in the Azure only. So in the Azure, we are having the service called as nothing but ADLS. So in the ADLS, we are going to store the data in the Azure. In the AWS, where we are storing the data in the S3 bucket. In the GCP, where we are maintaining all the data, all the files and in the GCS service. Like that, in each and every cloud platform, we are having the storage service. But here, mainly we need to understand, by using BigQuery, you can connect to the GCS, which is present in the GCP. By using the BigQuery, we can connect to the S3, which is present in the AWS. By using the BigQuery, what we can do, we can connect to the ADLS also, which is present in the one more platform called as a Azure only. Now, by considering all these statements, can we call it as a multi-cloud service or not? By using the BigQuery, you can able to connect to GCP services. By using the BigQuery, we can able to connect to the AWS services. By using the BigQuery, we can able to connect to the Azure services also. Indirectly, by using all these three statements, what we can able to say, BigQuery is one of the multi-cloud service. With the help of this feature, what we can do, you can connect to any cloud by depending on the requirement. And actually, we are having some other cloud platforms also, like Oracle Cloud and Alibaba Cloud. But at present, BigQuery is not supporting those platforms only. BigQuery is supporting only GCP by default, and BigQuery is supporting the AWS cloud, and BigQuery is supporting the Azure also. BigQuery is supporting all these three different cloud platforms. For the reason, indirectly we are calling BigQuery is nothing but one of the multi-cloud service. Okay. Any question on this multi-cloud service? Please ask me here.
Yes, sir. Is that the same concept like BigQuery is in AWS?
Sorry, can you please repeat?
Is that
Do we have the similar kind of concept like BigQuery in the AWS warehouse, right? Actually, in the AWS, we are having the one data warehouse system called as a Redshift only. But by using the Redshift, I think we cannot able to connect to the multiple clouds. I'm not sure that I need to check.
So,
but as per my knowledge, we cannot able to connect to multiple clouds.
So through BigQuery, we can access the data only, right? We can't process the data.
Yes. See, actually, so what is the purpose of the S3 here? For storing the data, which is nothing but you are retrieving the data from the S3. But if you are going to perform any kind of compute operations or processing operations, where all those operations are going to happen within the BigQuery. Okay, so see here, by using the BigQuery, just we are connecting to the S3 bucket, you are reading the data. After reading the data, if you want to perform any processing operations or if you want to perform any compute operations, those operations are happening on the AWS or those operations are happening in the BigQuery. All those operations are going to happen on the BigQuery. Okay, just to think that we are using the BigQuery to connect to the S3 bucket for reading the data, but all the operations are going to happen, all the compute operations or processing operations are happening within the BigQuery only. It is not happening on the AWS.
లొకేషన్ ఏం ప్రమర్ పెట్టినాను బెంగళూరు
Whoever not talking, can you please go on mute?
ప్రాజెక్ట్ లోకి అయితే ప్రాజెక్ట్ లోకి వెళ్తామంటే కనుక 2 to 3 లొకేషన్స్ ఉంటాయి. అది బెంచ్ లోకి వెళ్తే ఎక్కడైనా చేస్తాడు.
Hello, can you please go on mute? It's very simple. Only next time if you are talking to someone like this, I will remove them from the room because of one person it will disturb all the people. At the same time, it will disturb my flow also. So when we are discussing a topic very seriously, if any such kind of things are going to happen, it will disturb a lot. So please take care of your mute off operation. Okay, if you unmute unnecessarily, it will disturb all the folks. Around 70 people are here. You are disturbing 70 people. If you have any questions, please unmute and we can raise the question. Otherwise, don't unmute. It's my sincere request. Okay, coming back to the previous question. Hope it is clear, right? So we are
Sir,
by using the BigQuery, we are connecting to the S3 bucket only for reading the data. After reading the data, if you want to perform any kind of processing operations, all those processing operations will happen on top of the BigQuery only. It will not happen on the AWS side. Okay, any other
Sir,
questions?
yeah. From on-premise, we can able to migrate to cloud, sir, by using this BigQuery.
Yeah, we can able to migrate it. So that only we can call it as a migration projects. So by using the BigQuery, if you want, we can connect to the Teradata, and from the Teradata, you can able to read all the data, and that data you can able to migrate to the BigQuery. Okay, in the coming classes, we are going to discuss about by using the BigQuery or by using the GCP, how we can able to handle the on-premise systems. And at that point of time, we can discuss about how we can able to migrate from the on-premise system to the cloud systems. But for now, I can able to say for your question, answer is yes. Okay.
Sir, any particular reason they want to migrate from one cloud to another cloud, sir? Just want to know the reason.
No. See, if you observe here, they are not migrating only. In the same project, they are maintaining the AWS and they are maintaining the GCP. In some projects, what will happen is they will maintain. So actually, in the real time, we are dealing with the two different types of systems. And one is the OLTP and one is the OLAP. If anyone don't know about OLTP and OLAP, don't worry. In the coming classes, we'll discuss about what is the OLTP and what is the OLAP in the very detailed way. But if anyone know about the OLTP and OLAP, try to understand the statement. In real time, we are going to maintain the OLTP systems and OLAP systems. Okay. In some projects, what will happen is they will maintain all the OLTP systems in one cloud and they will maintain all the OLAP systems in the other cloud. Okay. In the situation, in between both the clouds, we need to maintain the communication, right? In such kind of projects, what will happen is we are going to maintain we are using some services to maintain the communication between one cloud to other cloud. Okay. Now, in this example, what I'm telling here, for example, in the AWS, in the S3 bucket, we are having all the OLTP data. Now, on top of that data, I want to perform the analysis by using the BigQuery. But where we are having the BigQuery, we are having the BigQuery in the GCP platform. That's the reason here what we are doing, just we are maintaining the communication between the GCP to our AWS. But to maintain the communication or to maintain that rapport, what is the service we are using? We are using the service called as a BigQuery. In the simple words, I can able to say, in some projects, in one cloud, we are going to maintain the OLTP systems. In other cloud, we are going to maintain the OLAP systems. And in such kind of situations, we need to deal with the multiple clouds by depending on our requirement. Don't ask me the question, what is the OLTP and what is the OLAP, because that is not relevant topic now. Definitely, we are going to cover that topic as part of our coming classes. Because of raising the question, just I'm saying that in the real time, we are going to maintain OLTP systems and OLAP systems. In some projects, both OLTP and OLAP will present in the same cloud. But in some projects, we are going to maintain OLTP in one cloud and we are going to maintain the OLAP in the other cloud. In such kind of projects, we can able to see the different types of the clouds in the same project.
Thank you, sir.
Yeah, no issues. Any other questions?
I have one question.
Yes, please.
In BigQuery, data will be stored in the column wise. So how it will maintain the relation?
One second. Did we discuss about the statement so far? See, I know some people are already having knowledge on the BigQuery and so actually BigQuery is going to store the data in the columnar format. I agree, but so far we haven't discussed about the statement. Now, certainly, if you are going to ask the question and if you are going to ask the relevant questions on the columnar format, immediately what will happen? New people will get a lot of confusion.
Okay.
Hope you understood, right? We'll discuss about that. So BigQuery will store the data in the columnar format. What is meant by columnar format and how the data is going to store in the columnar format, that we'll discuss definitely. But that is a not relevant question so far. Whatever the topics we discussed above. Okay. Any other questions relevant to the topics whatever we discussed so far?
Sir, is there difference in advantages of BigQuery in GCP, AWS and Azure?
No. See, one thing here, in the AWS, do we have any service called as a BigQuery? Don't get the confusion here. So in the AWS, we don't have any service called as a BigQuery. In the Azure, we don't have any service called as a BigQuery. So what I'm telling here, by using the BigQuery, you can connect to the S3 bucket. So just for removing your confusion, I will say GCP, BigQuery from GCP here. Here also BigQuery from GCP. And here also BigQuery from GCP. Okay. In the GCP only, we are having the BigQuery. But what I'm telling here, with the help of the GCP service called as a BigQuery, you can connect to the GCS service. By using the BigQuery GCP service of the BigQuery, what we are doing, we are connecting to AWS. By using the GCP service called as a BigQuery, we are connecting to the Azure, which is nothing but where we are having the BigQuery overall, we are having the BigQuery in the AWS or Azure, or we are having the BigQuery in the GCP only. We are having BigQuery only in the GCP only. Now, by considering the statement, whether your question is valid, you are asking the question, which BigQuery is any disadvantages or advantages of the BigQuery in the different cloud platforms only. Don't get that kind of confusion. BigQuery we are having only in the GCP. Okay, but here I'm giving the statement as with the help of this BigQuery, by depending on your requirement, you can connect to the S3, which is present in the AWS. By using the BigQuery, you can connect to the ADLS, which is present in the Azure. That's the reason only we are calling it as a multi-cloud service. Okay, any other questions? I know today's topic is completely theoretical only, but try to understand all these things, because once you can understand all this theory, then automatically practicals will become very, very easy only. So whatever the points we are going to discuss here, we are going to discuss all these things as part of our practical sessions. Now, in the practical session, suddenly if I'm going to use the word called as a multi-cloud, what will happen? You will get the confusion. That's the reason. First, we'll try to understand all these features. Once you can understand all these features and all these kind of terminologies, then what will happen? From tomorrow onwards, we are going to start the practicals on the BigQuery. At that point of time, you can able to understand all the different features, whatever is available in the BigQuery while doing the practicals. But before going to the practicals, try to understand all this kind of theoretical information. If you have any kind of minute questions also, you can raise it. But please raise the questions relevant to the topics, whatever we discussed so far. With that, other people won't get any kind of disturbance. Any other questions so far, please ask me. Otherwise, we can proceed. Okay. If no question, just see here. Other than multi-cloud, what are the other options we are having here? I am saying that BigQuery is a highly scalable service. BigQuery is a highly available service. And these two are the words I am using here. One is highly scalable, and other one is highly available. You only try to give the answer. What is meant by scalability, as we discussed in the previous classes already? What is meant by scalability?
Increasing,
Decreasing the number of servers
decreasing
based on.
Yeah, by increasing or decreasing number of servers or number of resources by depending on the requirement. And by depending on the requirement, automatically if it can able to increase the number of servers or resources, or if it can able to decrease the number of servers or resources, that kind of feature only we can able to call it as nothing but scalability. But here what I'm telling, highly scalable. Okay, in the cloud already we are having the scalability feature, but BigQuery is providing the highly scalability feature. Now, for example, if, as I told you earlier, if you are dealing with 1 TB data, or if you are dealing with 10 TB data, or if you are going to deal with the 1 petabytes of data, are we going to worry about anything here? From our side, we are not worrying anything only, because it is a serverless system. For example, to handle 1 terabyte of data, internally it is using, for example, 10 servers. Now, suddenly you are going to deal with one more table that is having, for example, 10 TB data. Then what need to happen? Instead of having the 10 servers, it need to maintain the 30 servers. Now, suddenly we are going to maintain the one more table, which is having the 1 TB data. In this situation, for example, it need to maintain the 3 servers for the purpose of loading or for the purpose of retrieving only. But if you see here, one table is having 1 TB data, other table is having 10 TB data, and other table is having the 1 petabyte of data. You are running the select statement on this table. You are running the select statement on the second table. You are running the select statement on the third table. Internally, what is happening? By depending on the amount of data we are dealing from the table, automatically either it is increasing the number of servers or it is decreasing the number of servers only. As a user or as a cloud engineer, you are not doing any kind of operations. Just you are running the query. Once we are running the query in the backend, what is happening? By depending on the amount of data it is dealing, either it is increasing the number of servers or it is decreasing the number of servers only. For that reason only, simply we can able to call it as BigQuery is nothing but is one of the highly scalable service. By depending on the requirement or by depending on the data, automatically it will increase increase the number of resources in the internally, and automatically it can able to decrease the number of resources also internally. That's the reason only we are calling it as a BigQuery is a one of the highly scalable service. Okay. And in the same way, we are having the one more feature called as nothing but highly available feature. And in the BigQuery, we are having one more feature called as nothing but highly availability. This is the one more topic again we covered as part of our previous classes. What is meant by high availability?
To access any point of time.
You can able to access the data at 99.9999% only. At any point of time, you can able to access the data. Indirectly, there is no downtime if you are going to use the BigQuery service. At any point of time, you can able to load the data or you can able to retrieve the data. That kind of feature only we can able to call it as nothing but highly availability feature. Indirectly, these two features already we discussed in the previous classes as part of our cloud features only. For every cloud platform, we are having the features called as a highly scalability and highly availability. For every cloud service also, we are going to have the feature called as a scalability and availability. So as part of BigQuery also, we are having the feature called as a highly scalability feature and also highly availability feature. Okay. All these features are available as part of our BigQuery. That's the reason only here we are giving the statement called as a BigQuery is a cost-effective, serverless, auto-managed, multi-cloud, highly scalable, highly available related cloud based data warehouse, and this service can able to handle huge amount of data within seconds or minutes. So someone is not muted only. Just I'm removing this person. Just 1 minute. Pawan Kalyan Marni. Okay, so just a last warning, Andy. So can you please mute yourself, everyone? Okay. So BigQuery is a cost-effective serverless service, or we can call it as an auto-managed service and multi-cloud service and highly scalable service and highly available service. But what is the main purpose of the BigQuery? And this is the cloud-based data warehouse. And by using the BigQuery, what we can do here, you can able to handle a huge amount of data within the seconds or within the minutes because of having all these features. Okay, this is the detailed understanding of the BigQuery. But if you want to understand the very simple words, what we can able to say, as we discussed earlier, BigQuery is a cloud data warehouse. Okay, so in this simple statement or in this complex statement, still if you are having any kind of questions, please ask me here.
Sir, hello, sir.
Yeah, tell me please.
Am I audible?
Yeah, you're audible.
Okay, sir. Basically, in the starting, you said that as a cloud data engineer, basically our work is conversion of data into information, right?
Yes.
So, as part of the data warehouse system here definition, can we say that mostly our job is related to handling data warehouse system?
Yeah, exactly. See, actually, if you remember earlier also we discussed that as a cloud data engineer, every day with what we are dealing, you are going to deal with the data only. And if you are going to work as a cloud data engineer, in every meeting or in every discussion or with every person, you are going to talk with the data only. Indirectly, where we are maintaining all the data as part of our projects, we are maintaining all the data in the data warehouse system. See, in the data warehouse system, we are going to deal with the data. But for this data warehouse system, from where we are going to get the data? If you see the first statement, collection of data from different types of the sources, which is nothing but you are going to get the data from the normal database system, or you are going to get the data from the any mobile applications, or you are going to get the data from the any other applications, or you are going to get the data from the Hadoop system. From anywhere you are going to get the data, but from everywhere what we are getting? We are getting the data only. If you are going to get something from the database, what you are getting? Data. If you are getting the something from the files, what you are getting? Data. Or if you are getting something from the Hadoop, what you are getting? Data. Indirectly, everywhere we are going to deal with the data only. And coming to your question, Andy, as a cloud data engineer, in the real time, what we are going to do? Mostly you are going to work in the projects called as a data warehousing projects only. In this data warehousing projects, what we are going to do? We are going to convert unorganized data into organized format, which is nothing but whatever the different formats of data we are getting, we are converting all the data into the proper format by depending on the client requirement. But why we are converting that unorganized data into organized format? As my end user or as a business people, they want to take some kind of decisions. To take the decisions, what they need to do? They need to do the analysis. To do the analysis, we need to provide the unorganized data or organized data. We need to provide the organized data. Now tell me, whose responsibility to provide the organized data in the data warehousing projects? as a cloud data engineer, it is your responsibility to provide the organized data by depending on your requirement or by depending on the business requirements. By depending on the business requirements, we are converting the unorganized data into organized format. But where we are doing these operations in the projects called as a data warehousing projects only. And after converting the data into organized format, our end user or business people are going to perform the analysis for the purpose of taking the decisions. Okay. Now tell me, as a cloud data engineer, are you going to perform any kind of analysis in the real time? No. Are you going to take any kind of decisions in the real time? No. Just you are going to convert unorganized data into organized format, and just you are sharing the data to your end user. On top of that data, your end user is going to perform the analysis and he is going to take the decision. This entire process we can able to call it as a data warehousing process. And if you are building a data warehouse system, that project only we can able to call it as a data warehousing project only. Now, as a cloud data engineer, in which kind of projects we are going to work? We are going to work in the projects called as a data warehousing projects. Is it clear?
Yes, sir.
Okay, good. Any other questions?
Sir, my question is like in data warehouse, once we store the data, we can't able to make any changes to the data once we stored in data warehouse.
Yeah, correct.
So is it possible in cloud, like if any like properties of data warehouse can be changed, or it will be same on the the cloud?
Whatever the properties of data warehouse we are having, same properties are going to apply on top of your BigQuery also, Nandi. Okay, because BigQuery is a data warehouse service, right? In the BigQuery also, it is going to follow the same properties of your data warehouse. Now, one more thing, tell me here, who said that in the data warehouse we cannot able to change the data? If you want, we can able to change the data, because in the data warehouse system where we are maintaining all the data in the tables only, right? You tell me, on top of the tables, can we able to perform the update operations or not? You can able to perform, but as per the properties of the data warehouse, you should not change the data. Don't do the statement. You cannot able to change the data. There is the difference between the both the statements, Andy. You cannot able to change the data is different. You should not change the data is different, Andy. You should not is nothing but there is the possibility to change the data, but you should not change the data in the data warehouse system as per the properties. Because, for example, my end user is doing the analysis on the historical data. For example, in the data warehouse system, we are maintaining last 6 months of data. At the same time, we are maintaining the current data, which is nothing but we are having current data plus historical data. Now, for example, you are going and doing the changes on the historical data. Anything, okay? You are doing the updates or you are doing the deletes and then what is going to happen? It will impact the analysis or not? For example, 2 days back, my end user did the analysis on the historical data. After 2 days, suddenly you came to the picture, you did the update operations on top of your historical data. Then what will happen automatically? Whatever the analysis my business people did before 2 days back, all that analysis is going to impact. At the same time, whatever the decision taken, that is also going to impact. That's the reason you should not change the data in the data warehouse system. But if you want, by depending on the client requirement, for example, client is coming back, he is given the requirement like this, Andy. I am seeing some disturbances in the historical data. Can you please modify the data? In that situation, do you need to modify the data or not? You need to modify by depending on the client requirement or by depending on the business requirement. So try to understand the difference between your statements, Andy. You are saying that you should not change the data and we cannot able to change the data. Both are two completely different statements. Here what I'm telling, in the data warehouse systems also, if you want, we can able to change the data by depending on the project requirement, by depending on the client requirement, or by depending on the business requirement. But that is not a best practice if you are going to work in the real-time data warehousing projects. Is it clear? Okay. Any other questions? Okay, so and don't take me wrong, because I'm asking the multiple times any questions, because all these are the very, very, very important things. And once you understand all these things, you can understand that BigQuery is a very simple thing as part of our coming classes. Actually, most of the people will say BigQuery is complex and BigQuery we need to spend a lot of time. Once you understand all these basic terminologies, once you understand all these theoretical things, and BigQuery will become as a very, very simple as part of our understanding or as part of doing our practicals also. Okay, that's the reason I'm repeating the same thing. Any questions, please ask me. Even if it is a kind of a complex question or minute question also, please open and ask the questions. With that, you can get a clear picture on top of our BigQuery service.
Yes, sir. I have a question.
Yes,
Where we peoples are also write the query in the job these things are in the data warehouses or
yes.
different.
See, if you're going
Means,
to use the
we
if
are-
you're going, one second, Andy. If you're going to use the BigQuery, most of the times we are going to write the SQL queries. Now, after writing the SQL queries, what need to happen? So, for example, by using the SQL query, you want to read the data, and by using the same query, for example, you want to load the data. Now, you want to perform this operation on the daily basis. So, obviously, what we have to do if you want to perform the operation on the daily basis, we need to create the jobs. Okay, because you want to do the same operation every day. Okay, every day you cannot able to come to in front of the system. For example, every day morning at exactly 10 a.m. I want to perform the same operation. Now, if you want to do it manually, what will happen? Every day morning at 10 a.m. you need to log in and you need to open the system and you need to connect to cloud and you need to do the operations manually. Sometimes if you forgot, you cannot able to perform these operations, right? For that reason, what we will do? We are going to perform the automating all these things only. To automate all these things, we need to do what we need to do. We have to create the jobs. Okay. This is the high level information, but what is a job? How to create the job? How to orchestrate the job, and how to run the job, and how to analyze the job. All those are the separate topics we are going to cover as part of our coming classes. But for now, for your question, I can able to say, if you are going to work in the BigQuery service, or if you are going to work in the data warehousing projects as a cloud data engineer, definitely you need to create the jobs and you need to orchestrate the jobs. And all these activities we are going to perform as a cloud data engineer in the real-time projects.
Means we are not going to do manually to run the jobs, right?
Yeah, we are not going to do it manually. That's the reason what I'm telling here. You need to create the jobs and we need to automate the process. For this reason, we are going to use the orchestration tools, or we can call it as a scheduling tools.
Thank you.
Okay, but what is the scheduling tool? What is the orchestration tool? That's a completely different topic that we'll cover in the coming classes. Okay.
Sir, one question here.
Yes,
Like
please.
some basic question.
Okay.
Yeah, can you please briefly explain that what is the futures of data warehouse? What that?
Yeah, see actually here, just to try to understand what is data warehouse and in the coming classes, we are dedicatedly going to discuss for 3-4 days on the data warehousing concepts. At that point of time, I will cover what all are the characteristics of data warehouse.
Okay, got it.
That's the reason I discuss about all these things as part of the today's session or as part of the previous session. For now, just to try to understand what is data warehouse. In the coming classes, we are going to cover about what are the characteristics of data warehouse and what is the data warehousing architecture. And within the data warehouse, we are going to maintain the two types of schemas. And one is the star schema and other one is the snowflake schema. Okay, other than this, we need to understand what is the fact tables and what is the dimensional tables. All these are the different topics we need to understand as part of our data warehousing projects. But all these topics we are going to cover as part of the sessions called as a data warehousing concept sessions only. So again, around we are going to spend 3 to 4 days of time on purely on these topics. At that point of time, in detail, I will discuss about what are the characteristics we are having in the data warehouse system.
Okay, thanks.
Sir, I have one
Sir, I had a question.
Yes,
Sir,
please. Yeah, please.
sir, I got an interview question yesterday that I got 10 files from, I got to transfer 10 files from GCS to BigQuery every day at a particular time. So how do I do it? He asked. So I said by using Cloud Composer. So and that is a correct answer, or can I? There is any other possible
Yeah,
ways
one
to
is by
do it?
using orchestration tools. Cloud Composer is a kind of orchestration. By using that, you can do. Otherwise, within the BigQuery only, you can able to schedule the queries at any point of time. If you want, you can able to run the query at a particular point of time. So you can able to schedule the. You are having the option called as a schedule the queries within the BigQuery. By using that, also we can able to handle this question or handle this requirement.
Okay, sir. Who can handle a number of files? Sir? Because he said I got 10 files from GCS to BigQuery. I need to perform create tables on that data like JSON or CSV file.
Yeah, you can schedule multiple number of queries. So you can schedule one query or multiple queries by depending on the requirement in the BigQuery. So what I'm telling is by using directly BigQuery, we can able to handle the situation, or we can able to handle the same situation, but with the help of the composer also.
Sure, sir. Thanks.
Sir, I have one doubt, sir. You have mentioned that compute, right? In the top, I think.
Yes.
Yeah. So can you please explain about that compute?
Now, see, for example, I think we discussed about our database concepts and everything, right? As part of database concepts, we discuss about some function, or we discuss about the count function, or we discuss about, for example, like operator, or we discuss about some more operators called as a and or not. Now, you tell me what are these? All these are the different operators we discussed as part of discussing about our database concepts only. Now, for example, within my SQL query, if I'm going to use the sum, what it will do, it will perform the summing operation. For understanding, we are discussing it as a summing operation, but internally, what operation it is doing? Can we call it as a computation? Yes or no? Internal.
Yeah.
In the internal database system, it is taking all the records from the table, and for what, for example, given the sum of salary, what it will do, it will go to the salary column. From the salary column, it will read all the values. On those values, what it will do, it is going to perform the summing operation. We are calling it as a summing operation, but indirectly, what operation it is doing? It is doing the operation called as a computation. Now, for example, we are given the count and it is performing the counting operation, but counting is nothing but indirectly computation. Now you are applying the filter by using the where clause. What is meaning of filtering indirectly? Computation. Okay, for example, you are applying the joins. What is the meaning of joins indirectly? Is a computation. On top of data, whatever the operations we are going to perform, all those operations simply we can able to call it as a compute operations, or we can able to call it as nothing but data processing operations. Okay, now same example. For example, in my table, I'm having 10 records only. Now I'm applying the sum of salary. Now you tell me, once we are going to apply the sum of salary, in the output you are going to get 1 record, or we are going to get the 10 records again. In my table, I'm having the 10 employees information as per our previous database example only. Now on top of the table, I'm giving the query called as a select the sum of the salary from the table. Now that query will give 1 record, or it will give the 10 records again.
Single record.
Only one record.
One record.
It will give only 1 record. Now you tell me indirectly, are we doing any data processing operation or not? We are converting 10 records of data into 1 record by applying what? Sum. Okay, that's the reason here this operation we can able to call it as a compute operation, or we can able to call it as a data processing operation. Or if you want, I can able to say, if we are going to retrieve all these 10 records, that kind of data, what we can able to call? Anyone can give the answer? What kind of data indirectly we are dealing here? If I'm given the select star from the table, you are going to get all the records from the table. That kind of data, what we can able to call? Can we call it as a detailed data?
Yeah, complete
Right. Now, for example, I am given the one more query called as select sum of sal from the table. Now, this we are going to get the output, but this kind of data, what we can able to call?
Summarized data.
Summarized data. Now, tell me indirectly what we are doing. We are converting detailed data into summarized format by using this SQL query. Will you agree or not? By using this SQL query, I am converting detailed data into the summarized format. Now tell me, are we doing any data processing operation or not here? We are doing the data processing operation. What is the data processing operation? You are converting detailed data into the summarized format. That data processing operation only you can able to call it as a compute operation also. So this is the way you can understand what is meant by compute operation or what is meant by data processing operation. Is it clear?
Yeah, clear.
Nice. Okay, so just we'll proceed further on it. So far we discussed about all these different features, whatever we are having on top of our BigQuery. And by using all these things, we given the definition called as a BigQuery is a cost-effective, serverless, auto-managed, multi-cloud, highly scalable, highly available cloud-based data warehouse. And this service we can able to handle huge amount of data within seconds or minutes. Okay, and again, this is one of the interview question. In the interview, simply they will ask the question, what is BigQuery? At that point of time, try to give the answer like this. Okay. Now, so actually all these are comes under the what are the characteristics of your BigQuery. Now, in the same way, just will try to understand some more characteristics or some more features on it. Just I will add one more thing here. BigQuery is a SQL friendly. What it means? In the BigQuery, are we going to write any kind of programs, or we are going to write the SQL queries only? We are going to write the simple SQL queries only. So once we are going to get the perfect knowledge on the database concepts, by using that knowledge, easily you can able to understand the BigQuery. That's the reason here we can able to say BigQuery is a simple SQL friendly operation, friendly service. Okay. So in the same way, we can able to say it is providing one more operation, one more service, one more feature called as a lightning fast queries. Okay, as per the previous statement, if you remember, if you are going to give the petabytes of the data here, your queries are running very fastly, or it is running very slowly only. If you are given the very huge amount of data, like petabytes of data, terabytes of data, what will happen? Your output is coming within the seconds. That kind of feature only simply we can able to call it as nothing but it is lightning the fastest queries. Within the short amount of time only, you can able to retrieve the data by using the queries. This is the one more feature we can able to say. And tell me, as part of using the BigQuery, do we need to configure any hardware systems here? Do we need to
We don't
configure
need to
any
do
stuff?
anything.
No
No
need
need.
to buy or no need to configure any hardware from our side at least. But in the backend, what will happen? Your GCP will take care of the server configurations and everything. But from our side, we are not buying anything separately or we are not configuring anything separately. This is the one more thing we need to understand as part of using our BigQuery. Now, in the same way, we need to understand one more important thing called as nothing but it will provide secure and control operation. So we can able to say here, big data service is a secure service, or we can able to call it as a big data service is a control service, which is nothing but whatever the data we are storing in the big data, no need to worry from our side about the security side, because it is using some kind of algorithm study internally. It is using Google algorithm to encrypt your data. If you remember, as part of the cloud storage only, whenever we are going to create the bucket, it is showing one option called as a encryption. In the encryption, what we can able to select? Anyone can give the answer? Can you please give the answer? While creation of the bucket, we saw one feature called as a encryption. In the encryption, what are the options we are having?
Google managed key and
Customized
CMYK.
One
encryption
is
and
Google is giving the
managed.
encryption service. By using that, you can able to encrypt the data. Otherwise, what we can do? We can
Customized.
able to write our own custom encrypt algorithm. With that also we can able to encrypt the data, which is nothing but by using the encryption feature, we can able to provide the security on top of your data only. So that's the reason here we can able to say your BigQuery is going to BigQuery is a kind of a secure service, or we can able to call it as a control service. Okay. Now in the same way, on top of BigQuery, we can able to say, as we told you earlier, we can able to say as you do. So what we are doing here, you are paying the money for only the amount of data you are using, or only amount of operations you are computing only. Based on the compute operations or based on the storage operations, only for that we are paying the money. We are not paying any extra amount of money as part of using our BigQuery service. But these are the kind of general things we need to understand on top of your BigQuery. But these are the main things only. Whatever the ones we discussed as part of our definition, these are the main things we need to understand as part of our BigQuery service. But other than these features, I'm adding the some more features here. By using the BigQuery, it is a kind of a SQL friendly service, and by using the BigQuery, you can able to run the queries very fastly, and no need to buy any kind of extra hardware, or no need to configure the hardware also whenever we are going to use the BigQuery service. And by using the BigQuery, you can able to provide the security for your data. And whenever we are using the BigQuery, just we are paying on what basis? Pay as you go. Okay. All these are some other features we are having on top of our BigQuery service. Okay. Now finally, you try to give the answer. What is the BigQuery? In the simple words, what is the BigQuery in simple words?
It is a cloud-based
Data warehouse.
database.
It is a cloud data
Cloud-based.
warehouse. Okay, that is the simple answer, Andy. But don't give the simple answers as part of your interviews. If you want to give the detailed answer, what we can able to say, by using all these things, whatever the features we discussed in detail, BigQuery is a cost-effective, serverless, auto-managed, multi-cloud, highly scalable, highly available, cloud-based data warehouse. And with this service, we can able to handle huge amount of data within seconds or within minutes. Okay. Now, whenever you are giving this kind of answer, then immediately they will ask the one more question like this, Andy. What is meant by serverless, or what is meant by scalable? What is meant by available, highly available? For that reason only we discussed about all these features in detail. This is the way simply we can able to understand what is the BigQuery service. Okay. Now, just for 3-4 minutes only, we'll see quickly practicals. With that, you can able to get a overview on the BigQuery. Now, for example, I want to open the BigQuery service. You try to give the answer how to open the BigQuery service. Now see here, if you want to open any service, what we discussed earlier, we need to go to our console.cloud.google.com, and within this, what we need to do here, we need to go to our navigation menu. If you see the navigation menu, here we can able to see all the list of the services. Only. Now, which service we need to open? I want to open the service called as a BigQuery. So if you want to open the BigQuery, we need to go to more products. And here you can able to see. We can see one section called as analytics only, and within the analytics here you can able to see the BigQuery. So if you want to open it, very simple, just we need to go to the console, Google console, and there we need to go to navigation menu. Within the navigation menu, where we need to go? We need to go to the BigQuery, which is present in the analytics section. But if you don't want to do all these operations, what's the one more option we are having? Simply here we need to go and just for search for BigQuery. Click on this. Okay, so once you are going to click on the BigQuery, then it is going to open the window like this only. So here you can able to see the welcome to your SQL workspace. So this is your BigQuery console. Okay, now in this BigQuery console, what we can do here is, if you want, you can able to create the databases, or if you want, you can create the tables, or if you want, you can able to write the queries and everything. But if you want to perform those operations, here we need to click on the option called as a compose a new query. Once you came to this console, here if you want to write any kind of SQL query, what we are doing, we are going to click on the button called as a compose a new query and just click on this. See, once you click on this, here it is going to open the query window like this. Now in this query window, you can able to write any kind of SQL queries by depending on your requirement. Now you tell me, in our MySQL database, if you want to write any kind of SQL queries, or first what is the query we ran in the MySQL, if you remember?
Yeah.
What is the first step? We need to create the schema, or we need to create a database only. In the same way, as part of using the BigQuery also, if you want to write the queries, or if you want to create the tables, first we need to create the database. But instead of calling it as a database here, we are calling it as a simply data set. We can call it as a database, or if you want, we can call it as a data set only. But if you want to create the database or data set here, we are going to use the query like this. You tell me, in the MySQL, if you want to create the database, what is the query we are using?
Create database.
Create database name. And coming to here, if you want to create, we need to give the query like this only. Create schema name. I'm giving the schema name is, for example, customer schema, semicolon. So in the MySQL, we are given the create database name, but coming here, what is the query we are giving? If you want to create a data set or database, we are giving it as a create schema name. Just to select the query by using the mouse, click on run button. Okay. If you see the left side panel only, you can able to see the database which you created called as a customer. But tell me, what is this QD sample? Any guesses? Whatever the database we created customer, that customer is coming here. But on top of the customer, at the beginning, we are having the QT sample only, which is nothing but this is our project name only. So for example, in your system, if you are having the multiple projects, first to select in which project you want to create the database. First to select the project. After selecting the project, then you can able to trigger all these kind of queries. What is the first query I triggered? I created a database, which is nothing but in the QT sample project, I am creating a database called as a customer. Okay. Now, for example, if you want to write the query, you can able to write the query like this also. Create schema QT sample dot customer. Now tell me what it means.
In QT sample project.
In the QT sample project, you want to create a database called as a customer. Okay. Now, for example, I'm giving the one more query like this only. I'm giving, for example, QT sample 1. Now, what will happen? This customer table will create in the QT sample project, or it will create in the QT sample 1 project.
Sample 1 project.
It will create it in the QT sample 1 project only. So that's the reason. First, we have to select the project here as part of creation of the schema. What is the best practice? We need to give the directly schema name, or better to give it as a project name dot schema name. What is the best practice? Best practice in the real time is at any point of time better to give it as a project name dot schema name, and that is the best practice we need to follow as part of our real time system. Okay. Now, for example, I want to create the table. How to create the table in the MySQL? Create table. Table name. I'm given the table name is, for example, customer underscore T1. After that, just to open the bracket, then we need to give the column names, and I'm giving, for example, ID integer, comma, I'm giving the name, for example, name, I'm giving it as a string. Actually, in BigQuery, we cannot able to give it as a varchar. Instead of varchar, what we can do here, we can give it as a data type called as a string. Okay. We'll discuss about all these things in detail in the tomorrow session. Just I'm giving the high level glimpse to understand how easy BigQuery as part of using. So if you want to create a schema, just we are using the same query, whatever we discussed in the MySQL. In the same way, if you want to create the table also, what we can do here, we are going to use the same query, create table name, and we are giving the column names and data types only. But tell me here, before the table name, do we need to provide any other information?
Yes, we have to mention the data set.
So better to give the data set name or database name. And what is the database name here? Customer. Tell me, can we give any other things here before the schema name?
We can give
project name.
See, actually, this is the best practice. I can able to say better whenever you are going to create the table, give it as a project name dot database name dot table name only. That is the best practice you need to follow as part of your real-time project. Now, after giving all these things, just I'm going to run this query. Click on. Now see what happened, table has been created. If you see in the left side panel, in the Qt sample project, under the customer table, it created the table called as a customer underscore T1. Okay. Now you tell me, I want to insert the data in the table. How to insert? Insert into
table name Qt sample dot customer
and copying this entire table name here. And giving it as a values. So how many columns data we need to pass? We need to pass the 2 columns only. For example, I give you 1, 3. Okay, so this is the way you can able to frame the query. So just we have to do it as a insert into our complete table name values and given the values and so just select the query and click on run button. So with that, what happened? Data has been inserted into your table. Now I want to see the data. How to see the data?
select star from
Star from table name semicolon. Just run this query. With this, you can able to see the data on your output screen. So how many records we inserted? I inserted only 1 record. For the reason, it is displaying only that record on top of your output screen. Now you tell me, all these operations are simple or complex? Once you, if you really completed the practice on our database concepts by using the MySQL only, then I can able to say BigQuery also will become as a very simple. But actually in the BigQuery, we are not going to perform these kind of operations only, but mostly, so we are going to write these kind of queries only. But in the BigQuery, we are going to perform some different types of operations as a cloud data engineer. But as part of using the BigQuery, mainly you need to understand most of the time, again, we are going to write the SQL queries only. That's the reason I started the database concept. So 10 days before itself only. Now, if you really doing the practice on the database concept, then automatically what will happen? Understanding BigQuery is a very easy. If you are not doing the practice on database concepts, what will happen? You cannot able to understand the database concepts. At the same time, you cannot able to understand the BigQuery. That's the reason. Please do the practice on database concepts. With that, automatically you can able to understand the BigQuery concepts only at the same time. So today, just I given the high level glimpse how we need to use the BigQuery from the practical side. From tomorrow onwards, we are going to cover all the practical sessions on top of the BigQuery, which is nothing but you need to do the practice on the BigQuery. At the same time, you need to perform the practice on the database concepts also in parallel. With that, you can able to get the perfect knowledge about all the topics, whatever we are discussing as part of our classes. Okay. Any questions up to here?
Yes, sir. I have a question. In real time, you need in all time in the UI side, or have you any other option like?
You want to tell me earlier what we discussed, Randy? Every service we can able to handle from the console. This is the console or cloud SDK. This is the console. Okay, from the console, we are doing all these operations. What are the other options we are having if you want to perform any operations on the cloud services?
SDK.
You can do the same operations by using the cloud SDK. Otherwise,
Python APIs.
by using Python programming. Okay, with the help of the Python scripting or Python programming, also you can able to perform the same operations. First, we will actually for the cloud service also, if you remember for GCS, what we did. First, we did all the operations from the console. Then we did all the operations on the SDK. So for the compute engine, what we did, Andy? First, we did all the operations from the console. Then we discussed about how to create the machines from the SDK. In the same way, coming to BigQuery also, first we'll try to understand how to do all these operations from the console. Then we'll try to understand how we can able to perform the same operations from the SDK also. But in all these three services, so far we have discussed about how we can able to perform these operations by using the Python programming. Because what is the reason? Because most of the people don't know about the Python. For the reason, so far we haven't discussed anything on top of the Python only. So I think after 1 week we are going to start discussing about the Python. Once you people are perfect on the Python, then we can able to do the same operations with the help of the Python also. Indirectly, whatever the operations we are discussing, you can able to do the same operations in the 3 ways. One is the console, one is the cloud SDK, and one is the Python programming. But tell me in the real time which operation we are going to use. Either cloud SDK or Python programming. In the real time, you won't able to get the console access, but for understanding, for the practice purpose, first we are focusing on the console, then we'll focus on the cloud SDK, then we'll focus on the Python programming. Like that, by using 3 different approaches, we are going to discuss all these topics. Is it clear?
So that in the real time, we are working on the SDK only, right?
Yeah, we are going to work on the SDK or we are going to work on the Python only, Python scripting. Any one of the thing.
Got it. Thank you.
Thank you.
Yes, sir. We will maintain any complex queries like transformations and all.
Yeah, we'll write the complex queries and everything. So actually, just for understanding, we're discussing all these basic queries. Okay, so we are going to write the joins, subqueries, and all those kind of complex queries we have to write. We'll discuss all those things. Don't worry. Okay. Yeah, that's all for today from my side only. If anyone want to disconnect, you can disconnect. If anyone having questions, you can ask me. If you people are not having any questions, you can talk. No issues. Any other questions?
Yes, sir.
Yes.